Does this thing work? All right, apparently it works. Hi, I'm Alex. So I head up Evariste Systems, which, as previously discussed, is very involved in Kamailio implementation in the North American market. We also do some SIP and Kamailio training. And the market that we serve is almost entirely service providers. Service providers of various kinds. That includes your traditional wholesale SIP origin term providers, as well as application service providers that in many cases are consumers of high-performance call processing systems that we build and a Class 4 routing product that we sell. So we're sort of empowered to broadly watch where things are going in the ITSP arena specifically. It's a very customary Kamailio constituency, but it's still a very important one. So I think that the conventional wisdom about ITSP infrastructure, large scale but especially small scale, from the 2000s and even into the early 2010s, was kind of cloud averse. I think the thinking is that, well, cloud and AWS especially, this was all built for web weenies and is kind of a glorified Node.js and Ruby on Rails hosting service, which it absolutely is. But there is still kind of, well, we'll get there in a minute, but the thought was, well, let's build big boxes. Big boxes that have actually, got to be quite competitively priced. And let's devise our own failover, high availability solutions with the usual kind of heartbeat and pacemaker folk traditions and the rest. And at least at a small scale, we would then own the entire responsibility for the availability of that infrastructure. I think there was a big cliche that cloud and virtualization are hostile to anything involving media and real-time communications involved, well, anything. Widely thought to lead to jitter and poor call quality in that. And in general, that real-time communications are special and require artisanal, boutique kind of treatment in the infrastructure realm that differs to that of the relatively high latency, asynchronous, best effort web world. I think that was the consensus, at least in the small to medium ITSP arena in the mid-2000s, even in the early 2010s. And then things started to change. And I think the big shift that we've seen in the last couple years is that ITSPs actually are embracing major cloud providers like Azure, AWS, and Google Compute Engine now. Mostly in the developed world. Unfortunately, the POPs for these things are somewhat limited elsewhere. As I just said, AWS and the rest are actually not perfect for media and real-time communications handling and really do introduce anomalies. But there's a kind of just good enough phenomenon in capitalism which occurs everywhere in terms of how markets rationalize these things, these kinds of inputs. So for example, there was a fairly widespread consensus in even the late 2000s in my experience that, if you want good call quality, well, you can't run it over the public internet. That's where good phone calls go to die. You need dedicated circuits or TDM or what have you. And then at some point in the last decade, that started to change. I can't pinpoint exactly where and when. It probably happened in different places at different times, but I think everybody in this room kind of takes for granted that you can run a G711 phone call over your public IP internet backbone at least in developed economies and do just fine. Maybe not necessarily in a way that meets the stringent SLAs and demands of certain types of customers, but on a widespread mass market basis, absolutely. And most hosted PBX providers and ITSPs do operate that way today. And the other thing that has changed is that the nature of virtualization has evolved. Virtualization went from being a very software emulated and slow thing to something that's almost a first-class tenant on your CPU and makes use of a lot of CPU instruction sets and hardware capabilities. In other words, a virtual machine running inside a mainstream hypervisor is much closer to the metal, thanks to paravirtualization, than it was in 2006. And the other thing that's driving interest in cloud, of course, is just the general widespread belief in the divestiture of non-core competencies, which in the thinking of a lot of service providers is operations. They really see themselves to be higher up the value chain and don't want this low margin metallic bit banging and swapping out hard drives at 3 a.m. They don't really want to own that problem. At least dedicated servers do effectively solve that problem, but that kind of creates a layer of indirection and removal, but still requires them to fundamentally be responsible for pieces of infrastructure. And I think there's a widespread belief that if we just fire all the people that do that and focus on delivering service, we'll be better off. And then, of course, cloud is just fashionable, and there is a mimetic aspect that drives the unremitting enthusiasm for it, absolutely. When these executives go to the country club and hear about how fruitfully cloud is being utilized by their web friends, they can't help but think, well, are we missing out on all this cloud stuff by doing the very pedestrian thing of running servers per se as such? So the other really tantalizing thing that they're all after is, well, if we could just fire all these sysadmins. Good sysadmins are actually quite expensive and very often seen as a cost center. Unless you're really in the infrastructure business, frankly, they often are. There's a tantalizing aspect to being able to fire the perceived gophers that go to swap out hard drive trays at 3 a.m. That's what the CXO suite is thinking when it looks at the business case for cloud in a service provider environment, in our experience. So most software-defined infrastructure that delivers SIP service, class 4 and 5, soft switches, SBCs, and the rest, have been built on the big fat box model of telecom infrastructure, which is to say, it's a big multi-core server with lots of RAM, fast storage, gigabit NIC, and most platforming endeavors, involve kind of allocating a small number of these into some sort of high availability cluster. Frankly, that's where our class 4 platform is today. It doesn't matter whether you actually own and buy the server or whether you build your network out of leased dedicated servers. You fundamentally own operational issues related to them. And that requires system admins, data center remote hands, and other care and feeding. Unless you're doing this in a very large-scale, capital-intensive way, whatever high availability solutions you devise for this type of infrastructure will tend to be kind of self-limiting. The other thing is, the actual applications and the infrastructure that runs on these things. I mean, what's a server if it doesn't run anything, right? Typically consists of big centralized services, big centralized APIs, big centralized database, big centralized proxy, lots of aggregation, and a focus on optimizing throughput through one thing. I mean, what is Kamailio's claim to fame historically? It's the incredible amount of throughput that can be achieved on commodity hardware with very, very little overhead, right? These are all things that are very complementary to building centralized applications. And this is a diagram from somewhere in our product documentation that illustrates the kind of infrastructure that you typically have. So we put out a class 4 routing product based on Kamailio called CSRP. And it consists of it's a very database-bound workload because it has a lot of business logic and business features. And it's the usual, primary database, secondary database, proxy, media feature server, some kind of API or GUI, some kind of API or GUI. So then the question becomes, well, should I put all these services on my primary server and then have a secondary one running a mirror of them for standby and then some kind of replication? Or should I attempt to distribute them in a slightly more particularized way? But at most you end up with, a quarter rack full of servers, and now you're running a CSRP cluster. So when you know, it's not necessarily an unreasonable way to build things. There's still a perfectly adequate business case for that. But if you're taking this stuff to the cloud, I think a common pattern that we run into is you'd simply take something like that, what I call the big fat box model, and you simply run it in the cloud instead. Well, that doesn't work. That doesn't work at all. That doesn't work for a number of reasons. The first thing is that the pricing will not support that approach. You take a box that runs CSRP today in a kind of monolithic manner and you try to run it in AWS at specs that are not even necessarily equivalent, but reasonably at parity for what you're trying to accomplish with a modest workload, you're going to end up with a $1,000 a month instance. Whereas you could get a sub-$100 US a month dedicated server with the aforementioned specs just about anywhere now. That's the kind of thing that you're looking for. Not going to save any money that way. And I think the other thing to consider is the essence of a cloud-based application fabric really is not in simply putting. I mean, what's the joke, right? There's no such thing as cloud. It's just someone else's computers. We've had hosted applications for about as long as the public internet IP backbone and last mile connectivity could reasonably support that kind of thing, going back into, I guess, the early 2000s, really. Simply taking something like our product, the way we've built it, or a lot of other mainstream switch platform products out there, and just running it in the cloud is not getting cloud. If you want to build a cloud-native application, you have to build it the cloud way. And the salient characteristics of that are that it's distributed, that the componentry can dynamically discover other parts of the componentry and assemble itself, that it's elastic and does scale up and down in response to shifts in workload, and that the dimensioning of this componentry is fitted to kind of the unit economics of the platform in which you're running it. Typically, when you take something like CSRP or many other soft switch products out there and multi-tenant systems and so forth, and you try to put them in a cloud context, you are almost certainly going to have to do a lot of re-architecture. We run into the common thought process that, well, if we just change the distribution model and pack it away into containers, but otherwise keep it the same, then it's all good. Well, no. All those components you saw in our diagram could indeed be containerized or made into VM images, but that does not, for elastic dynamic scalability, make. Yeah. So just breaking those components up and making them more portable is not cloud native. And you still need people to build and run all this. It's just perhaps the skill set has slightly shifted under their feet. You still need strong Linux sysadmin folk traditions. These are all still Linux hosts. And I can't tell you how many problems we run into with the generation of people that think that SSHing into a server is really dropping down to the bare metal, and it's almost like assembly to them. The only thing they've really ever known is how to push deploy to Heroku or whatnot. No, you still need strong Linux fundamentals to run this kind of thing. It's just that skill set has been updated since the classic heyday of Linux system administration Classic Edition in the mid-2000s to include things like orchestration, whether it's Ansible or SaltStack, or I guess if you like to do things the hard way, Puppet or Chef, or discovery and synchronization mechanisms. In the case of AWS, that sometimes calls for making use of its native load balancers and other complementary services that they will sell you on a la carte basis. But systems like Consul or Surf, or if you have a lot of moving parts, then Kubernetes. You need somebody who understands how those things work. Cloud platform APIs and automation are typically highly complementary to this. You want to spin up more instances of media servers. chances are you're going to be calling into an API to do that, to invoke more instances from an image or something like that. APIs are typically a big part of the plumbing that goes into building something on top of cloud. And then, of course, understanding just the idiosyncrasies of cloud platforms. We're going to talk a little bit about that on the next slide. There is, as a general rule and as a general pattern, more dev to go with the ops. I mean, there's some reality to the otherwise slightly airy term DevOps. The unexpected factors for ITSPs as they take the big box mindset and try to kind of parlay it into cloud are mainly the following. So first of all, big instances are very expensive, so you can't build things out of them. I don't have a lot of experience with GCE or Azure pricing. I can tell you in AWS land, what they really want you to do is to buy lots of small to medium instances. They don't want you to buy large instances. That messes with the oversubscription economics and the unit pricing that they have devised. So, for example, if you're relaying a lot of RTP and you want to build the one true RTP engine, the one that can, handle tens of thousands of calls through it, or even in the 5 to 10K range, you're not going to build that on AWS because it's not what, or if you do, you're going to end up paying $4,000 a month for it. That's not what they want you to do. They want you to have 10 medium instances that do the same thing. And one of the ways that they're going to enforce that is they're going to introduce a lot of PPS and bandwidth limits, some of which are not necessarily obvious or published. But even when you have an instance that has adequate CPU, adequate specs, and lots of other characteristics that lead you to believe that it's a fairly solid workhorse server for network I/O bound work, you'll suddenly find that you can just top out at 15 megabits of RTP for no discernible reason. These are all things you have to get savvy to, and they're both explicit and somewhat covert characteristics of the product that you're being offered. There are still occasional scheduling, contention, and hypervisor issues. It is a reality that, at least in the case of AWS was not built for real-time communications. It's just being put there anyway. Network and reachability issues sometimes surface as artifices of the cloud product, and that kind of goes with the statement about arbitrary resource limits, but also, if you've ever tried to do multi-region, multi-zone deployments into AWS, you find that either suddenly you need to sign up for the a la carte internal VPN plan, or devise some really kind of contorted contrivances of your own to network your availability zones or regions together, often using software-defined routing infrastructure of your own and so forth. All of which you didn't really have when you just had a data center with multiple POPs in multiple cities that could offer you a private backbone with essentially unlimited throughput. And speaking of unlimited throughput, you should in no way take for granted that either the peered internet transit bandwidth available out of those sites, or even the backbone throughput that you can get to the rest of your infrastructure and other sites is necessarily unlimited, or that its limitations or unit economics are even fully disclosed to you. Will you save money? Well, we've seen some instances of that from time to time. We've also seen some instances of OpEx shooting through the roof. But hey, at least we don't have to employ as many sysadmin. So it all depends on whether you effectively make use of the unit economics and pricing picture that you're being presented. And I think that if you try to take some of the big fat boxes forward and just have these platforms host them, you're going to rapidly run into the economic limits of that thinking. And will you reduce risk and improve availability? In terms of failover, storage availability, and straight up server failure, yeah, you will. But you will definitely inflate a different part of the balloon that relates to having to battle issues with the cloud platform itself at a broader, more macroscopic level. They can and do have outages, and can and do have performance quirks of their own. So your internal organizational culture, tooling, institutional memory will need to adapt to service a different kind of master than when you are mostly slinging big fat boxes. Some features of Kamailio that are complementary to cloud native development include an increasing emphasis on hot reloading. So for example, you've noticed in recent major releases that you can now reload your RTP engine sets. They can be described in a database, and you can kick Kamailio to reload them without restarting. That's the kind of thing that's really a dog whistle to the cloud architect people. That's saying to them, hey, we know you need more of these in the daytime, and we've got a solution for you. Same thing is true of dispatcher and just more extensive RPC and introspection of what's going on inside Kamailio in ways that can be wired to monitoring, APIs, and orchestration. Kamailio does have a magical ability to fall back to mostly stateless relay, except for certain hop-by-hop messages like cancel. But that goes very well with the sort of increasingly anycast-oriented thinking of cloud deployments. Database synchronized approaches to sharing registration are generally not so great for cloud because of the sheer amount of bandwidth they consume and the fact that the database layer you're using, depending on how you've chosen to structure your deployment, may or may not be customized and somewhat simplified, as is generally the case with the cloud versions of these offerings, like something like Aurora, let's say. So in general, if you've relied a lot on database as IPC and database as a synchronization mechanism for clustering, you're probably going to find that the underlying infrastructure in mainstream cloud providers is not going to cater to that as well, particularly since there's no real guarantee about the intermediate network between these components. It's not like when they both sit in your own rack on a gigabit LAN that you're free to manage as you like. To that end, DMQ being by nature asynchronous and lighter weight and making use of native SIP has really been a godsend for the type of work that we do in this area. And I think that application layer replication will become more of a first-class objective for clustering in these environments. Kamailio can do very flexible logging, and with flexible logging comes flexible searching and flexible classification, flexible invocation and environment for container execution. There's been a lot of work here done in the community with strapping Kamailio into Docker containers and so forth, and the fact that Kamailio is elastic in that regard and lends itself readily to containerization has been a big benefit. The async client for HTTP is useful for kind of self-provisioning HTTP REST API interactions, and also a lot of options related to the ever-popular one-to-one NAT approach that's often seen in cloud networking. That is to say, the ability to bind to a private address while making convicted outward assurances to third parties that your address is actually this public IP. An RTP engine can do the same with its relay interfaces, and that's really beneficial. So with that in mind, I think we're right on schedule. Questions?
Yeah, thank you, Alex. Are there any questions?
Hi. Not sure you can answer this right away and very fast, but you've shown the picture of a big fat box. But do you have some kind of the same idea how you transform it into, for example, to the AVS? So it means what technology exactly you used in AVS, means how you translate it, like Rosetta Stone from one to one.
Mm-hmm. Well, as you noted, the answer is going to be very specific to what the implementation is. But for example, in CSRP, we rely a lot on database stored procedures and triggers, and a lot of really database internalized business logic. So like an RDS version of Postgres would be non-viable for us because it doesn't have the full range of feature set needed to accommodate that. So in that case, your cloud architecture would would take into account the need to run your own database instances, and with it, the instance sizes needed to do that, and the pricing that goes with that. But if you're just using your database, for example, to just store data, tables, not a whole lot else, then you're very flexible in the options that you have, including using the cloud-native ones, which, of course, the cloud providers very much would like you to do, since that becomes a premium line item on your invoice. But there's a lot of reasons why it also makes a lot of sense from a redundancy and availability point of view. If you're going to embrace the cloudy way of doing things, you're going to get a certain amount of vendor lock-in and kind of proprietary approaches that come with that, but that's part of the bargain. That's part of the social bargain that you're entering into. But at a general level, it is kind of hard to answer that question. I'm sorry.
Okay, other questions around?
Hi. What's your opinion about using private, I'm here, about using private clouds like OpenStack or things like this instead of Amazon? It won't be cheaper, definitely, but do you see it as some useful use case?
So are you thinking more of like building an own cloud or a hybrid type approach?
Yes, exactly. If you had the big fat box, just use it for cloud instead of running the SIP service and virtualize on top of it.
Well, I personally have a very high opinion of that approach. The sort of economic and strategic agenda that is driving a wholesale movement into cloud and cloud-native environments by many service providers is precisely to get rid of stuff like this, though. So it's when the execs think, no, it's not cool. No, we don't want to hire people to run our own OpenStack cluster. Shouldn't be our problem. We're in the SIP minutes business or the hosted IVR business or whatever. They don't want to be in that business. So by definition, you've asked a question that goes against the grain of the sort of the organizing principle of the sample set that I have picked here.
Thank you.
Yeah.
Okay, so I think if someone has more questions, should grab Alex, because we are more or less finished with the time, or? And Alex will be around, and trust me, he likes speaking, talking, so just get in touch with him. He can explain everything. So
Yes.